Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered why some things just stick in your brain from childhood while others feel like learning a new language all over again? Well, this study dives deep into why that happens, especially when we learn words that are actually made of two words stuck together. Think about words like yearbook or toothbrush. They're made of two smaller words, right? This research asks if we see these compound words as one whole thing, or if our brains treat them more like two separate ideas, and how the age we first learn these words affects how easily we recognize and say them. It turns out, learning something when you're young makes a big difference compared to learning it later in life. This is called the age of acquisition effect. So the big question here is about compound words. For example, year and book together make yearbook. Do we process yearbook as one single thing from the start? Or do we break it down into year and book? And does it matter when we first learned year and when we first learned book to understand yearbook? The researchers figured that compound words are tricky because they need more mental heavy lifting to figure out their meaning. They had 48 students play a couple of games first, an object decision task. Imagine seeing a picture and you have to say if it's a real object or a fake, scrambled one. This task is more about just recognizing the object's shape and overall look. Second, a picture naming task, where they had to just say the name of the object as fast as they could. They measured how quickly people recognized the objects and how quickly they could name them. Then they did something clever. They subtracted the time it took to decide if an object was real from the time it took to name it. This subtraction helps them look at the specific parts of the process, like finding the right word from your memory, which is called lexical access, and then figuring out how to say it, which is phonological encoding. And what did they find? Big news. Words learned earlier in life were recognized and named faster across both tasks. This confirms the age of acquisition effect is real. But here is where it gets really interesting. When they looked at the combined effect, especially the difference between deciding and naming, they found that the age we learned the whole compound word mattered, not just the age we learned its individual parts, like year or book. This means our brains are treating compound words like yearbook as single units. If our brains were breaking them down into year and book all the time, then the age we learned those individual words would have a bigger impact. But it seems like the learning age of the entire combined word is what's important. The study supports what's called the integrated account of the age of acquisition effect. This idea says that things learned early on are wired into our brains more strongly, almost like they're part of the core network. Later learned things have to fit into an already established network, which takes more effort. It's like building a house. The early structures are the foundation, and you build on top of that. One theory, called the representation theory, suggests that early learned concepts are more central in our mental dictionary, with more connections to other words and ideas. This makes them easier to access. Another theory, the mapping theory, focuses on how our brains learn the connection between a word's sound phonology and its meaning, semantics. Early on, our brains are more flexible, making these sound meaning links very strong. As we get older, the brain becomes less flexible, making it harder to form those strong connections for new words. The cool part is these theories aren't enemies. They likely work together. The researchers found that both the object decision task, which is more about visual recognition, and the picture naming task, which is more about speaking, showed this age of acquisition effect. But it was stronger in naming. This suggests that both how our brain stores word meanings and how it links sounds to meanings are influenced by when we learned the word. The fact that the whole compound word's age of acquisition mattered, and not just the parts, is a key takeaway. It suggests that when we learn words like toothbrush, we don't just learn the meaning of tooth and brush all over again in a new context, we learn toothbrush as a single distinct concept. This research strongly supports the idea that compound words are treated as single units in our minds, at least in terms of how their learning age affects processing. Our brains prioritize the complete word itself, rather than constantly reanalyzing its constituent parts. This is important because it means the mental dictionary isn't just a collection of single words. It also contains these units. And the age at which they were acquired is how they're organized. Now, every study has its limits. One thing the researchers mention is that the order of the tasks might have played a role. Since participants did the object decision task first, they saw the pictures and their names before they had to name them. This could actually make the words feel more familiar, potentially reducing the age of acquisition effect a little bit. Future studies might want to wait longer between tasks or have different groups, do the tasks in different orders to see if that changes anything. Also, they used drawings that were kind of like a mix of real object parts and nonsense, chimeric non-objects. While this is good for their object decision task because it makes sure people aren't just recognizing a familiar object, it might not perfectly represent how we process truly unreal things. Future studies could use even more abstract or novel stimuli. But overall, this is a super interesting study that gives us a powerful insight into how our brains handle language. It confirms that learning things when we're young gives us a lasting advantage. And it shows that for compound words, our brains are pretty good at treating them as whole packages. This helps us understand the complex machinery of our minds and how it stores and retrieves information. So, what does this mean for you? It's a reminder that those early learning experiences really lay down strong pathways in your brain. And it shows that the way we learn words, especially complex ones made of multiple parts, is a fascinating interplay of meaning, sound, and the developmental history of our vocabulary. It's a testament to the plasticity of our brains, especially when we're young. What do you think about this research? Does it surprise you that compound words are processed as a single unit based on their learning age? Let us know your thoughts in the comments below. And if you enjoyed this dive into the science of the mind, please give this video a thumbs up, subscribe to RUBIN'S Mind Lab for more amazing research breakdowns, and hit that notification bell so you don't miss our next episode. Thanks for watching, and we'll see you next time.